In this video, I'm going to explain properties of logarithm. Here we have 11 properties. We are going to solve some questions about all these properties. But here, the first one is important because almost all the questions we are going to use this method. Logarithm base AA is equal to 1, or logarithm base A1 is equal to 0, and here this one, the sixth one and the fourth one. For sixth and fourth one, actually they are similar properties. While logarithm base AA is equal to 1, if we write this one, it should be A is equal to, this comes as the base of the exponential expression, so a to the power of 1. So a is equal to a, it's going to be. It means that logarithm base 2 is equal to 1, logarithm base 3 is equal to 1, logarithm base root 7 is going to be equal to 1. All these expressions, they are going to be equal to 1, and here only the important part, base and the main part, which is called the argument also, they are going to be equal to each other. Okay, the second one, logarithm base A1 is equal to 0. This is obvious normally. 1 is equal to a to the power of 0. So for any a, for any a 2, 3 except 1, a to the power of 0 is equal to 1. It's going to be, except a cannot be equal to 1. This is the definition of the exponential form and logarithmic form. Okay, so logarithm base 1 is equal to 0. Logarithm 1 is equal to 0. Logarithm 1 is equal to 0. It's going to be again. Yes, here are some applications. Logarithm base 1 is going to be equal to 0. 23 is equal to 1. Here we know this one because 23 to the power of 0 is going to be equal to 1, or 23 to the power of 1 is going to be equal to 23. If we give another example, 15 to the power of 0 is equal to 1. 15 and 15 to the power of 1 is going to be equal to 15. Okay. Yes, this is the property about the sixth one that I showed. Here the powers comes in front of the logarithm sign, and the numerator's power, it should be the main part power. Yeah, the numerator here, it should be the main part's power. And the denominator's power, denominator's value, it should be the power of base 6 here. If I give another example, -1 written up, -8 written down, and logarithm base 7. This part is not going to change. Here logarithm 4, 8 minus 3, so it's not going to change. Here we have the we are going to use these properties. That's why I add these properties here. Logarithm base 216 is equal to what? If we say these are all equal to x, here x, and x. Here we don't know the x values, and we are trying to find the x values. There are two ways to solve this question. The first way is exponential way. You can convert this expression like 16 logarithm base 216 is equal to x, and you should write the base of logarithm as exponential base, and 16 becomes, this implies that 16 is equal to 2 to the power of x, it should be, and 16 can be written as a power of 2, that's 2 to the power of 4. 2 to the power of 4 is equal to 2 to the power of x. Then this implies that x is equal to, because bases are same, x is this 2 value here, it should be equal to each other, so x is equal to 4, it should be. This is the first way. And the second way here, second way is the usage of this second property. Logarithm 216 is equal to 2 logarithm 2 2 to the power of 4. We know this one. And the power 4 can be written in front of the logarithm sign. Here, this power we can take in front of the logarithm sign, and it will be equal to like 4 times logarithm base 2, and we need to know this one. Logarithm base 2 always it's equal to 1. Logarithm base a always equal to 1. I use this property here. Then the answer is going to be equal to 4 again. Here, as you see, the results are same. In this question, I'm not going to solve. Not going to solve by both way. I'm going to solve only the second way by using the second way. Logarithm base 3, 243. It should be equal to logarithm base 3, 243. Ladies and gentlemen, you need to know this one. 243 is 3 to the power of 5. I need to get this 5 in front of the logarithm sign, so it's going to be 5 times logarithm base 3. Here, as you see, I'm going to use one more time this property. 3 is equal to 1. This is equal to 1, and it's going to be like this. 5 times logarithm base 3 is equal to 1. There's no need to write one more time that one. 5 times 1 is equal to 5. Okay, logarithm 927. Logarithm 927, none of powers of 9 is equal to 27. So we should find common term between 9 and 27, and that's 3. You know this one. Logarithm base 3, or let's write first the whole expression. 927 is going to be equal to logarithm base 3 square and 3 cube. Now this power comes to numerator like 3 here, this 3, and this power comes to denominator over 2 times logarithm base 3 and 3. Logarithm base 3 is equal to 1, so it's going to be equal to 3 over 2 times 1, which is equal to 3 over 2. Okay, the next question. Logarithm base 2, 8. Logarithm base 3 to 1 over 243, and logarithm base 2 root of 125. Let's start with logarithm base 2, 8. Logarithm base 2, 8 is equal to logarithm base 2 cube. It's this, and it's going to be equal to logarithm 3 logarithm base 2. Logarithm base 2 is equal to 1, so it's going to be logarithm, there is no logarithm anymore because it's equal to 1. 3 times 1 is equal to 3. Okay, we are going to write logarithm base 3 1 over 243. In the previous question, if you remember here, 243 we said it's equal to 3 to the power of 5. So this is equal to logarithm base 3 1 over 3 to the power of 5. Here we have to be careful. This is not the denominator's power, something like that. First we should write logarithm base 3 to the power of, here, if this number goes up, it should be equal to 3 to the power of minus 5. And if it is minus 5 times logarithm base 3 it should be, and logarithm base 3 is equal to 1. That's why the answer is minus 5. It should be. Okay, the last one. Logarithm base 2, 125. 125 can be written 5 cube. Logarithm base 2, 5 cube square root. And this square root can be written as a power of 1 over 2, or this 3 and this is 2, so that's the way it's going to be logarithm base 2, 5 to the power of 3 over 2. and 3 over 2 times this power comes here, 3 over 2 times logarithm base 2, 5. And we should leave like this because any power of 2 is not equal to 5. So we cannot write 5 in terms of 2 as a power of 2. We should leave like this. The answer is only this term. 3 over 2 times logarithm base 2, 5. We don't have any integer result for this question, like 3 or minus 5. Okay, if we find the logarithm base 9 here, how to get the powers in front of the logarithmic sign, this is the exercise about that one. And we should find the fifth power of 4. That's, I think, 2024, fifth power of. So the base is 4, and I'm going to check for the bases 4 here, this number. So it's going to be like this. I'm checking the base is 9, and here this one. This is the fifth power of 4. That's why it should be like this, and this should be here, the second one. And of course the base is 3, this one is the base is 3. The powers 81 is going to be 3 to the power of 4. 32 is equal to 2 to the power of 5. So this should be written in front of it. Okay, I'm not going to add that one. Yes, with the square roots. Here this question seems lots of terms, that's why maybe it seems difficult here than the previous questions, but normally it's very easy if you know the property about the here. If you know this property, nth root of a to the power of m is equal to a to the power of m over, and it's going to be so if I analyze root 27 first, for the first one, root 27 is going to be equal to square root of 3 cube. And the number what is not written here, we know, everyone knows this one. This is equal to 2. If you write exponential form of this one, it's going to be equal to 3 to the power of 3 over 2. If we rewrite this term here, logarithm base, this is the first one, logarithm base 3 square root of 9 square root of 27 is equal to logarithm base 3. Square root of 9 can be written as 3 square times, here I found that 27 is equal to 3 to the power of 3 over 2. 3 to the power of 3 over 2 is going to be, so that's equal to logarithm base 3 to the power of 2, 3 to the power of 2 plus 3 over 2, it should be. Okay, then it's going to be equal to, logarithm base 3. I'm going to write this one as exponential form. When you have the square root, do you know the power? It should be equal to 1 over 2. Okay, 3 to the power of 2 plus 3 over 2 also, it's going to be equal to 3 to the power of 2 times 2, 4, plus 2 times 2, 4, plus 3, it's going to be equal to 7 over 2. And to the power of 1 over 2, then the answer is going to be equal to logarithm base 3 to the power of 7 over 2 times 1 over 2, it should be, which is equal to 7 over 4. Then it's going to be equal to 7 over 4 times logarithm base 3, and the answer is 7 over 4, it should be. Here the operation a bit longer it's going to be because we have more terms inside the logarithm. B is logarithm base 2. Base is 2, so all these numbers as you see here, they're related with 2. This is 2 to the power of 4, this is 2 to the power of 3. So we should write them. Firstly, let me write all of them. 4th root of 2 times square root of 8 times cube root of 16. I'm going to write cube root of 16 first. See? Cube root of 16 is equal to cube root of 2 to the power of 4. So this is equal to 2 to the power of 4 over 3. 4 over 3 and 8 is equal to 2 to the power of 3. We know this one. So I'm going to rewrite these terms. Logarithm base 2. Here, let's write a bit bigger, I think. Base 4. Then 2 times square root of 2 to the power of 3 times 2 to the power of 4 over 3. If the bases are same, we should add the powers. You know this property. Logarithm base 2 fourth root of 2 times square root of 2 to the power of 3 plus 4 over 3. Then these two, if we add them here, it's going to be equal to 3 times 3 plus 4 is going to be 13 over 3. And I'm going to convert this fourth root and this square root into power form, and it's going to be equal to logarithm base 2 the power 4 and index 4 nth root of, if you remember, 1 over n. So fourth root here 1 over 4, it's going to be this fourth root as a 1 over 4, we are going to write here times 2 times here the power square root, that's why it should be equal to, I should maybe leave space a bit here, one more time, here the power 2 to the power of, if you remember, 3 times 3 plus 4, I said it's equal to 13 over 3 to the power of 1 over 2. This square root becomes here to the power of 1 over 2 and to the power of 1 over 4. If we continue from here, logarithm base, I'm going to start with this bracket, logarithm base 2 to the power of 2 to the power of 1 over 3, 2 to the power of 13 over 3 times 1 over 2, it should be 2 times 13 over 3 times 1 over 2 to the power of 1 over 4. That's equal to logarithm base 2 times 2 to the power of 13 over 6 to the power of 1 over 4, and that's equal to, here this is in bracket, but we have 2 to the power of 1 here also, that's why logarithm base 2 to the power of 1 plus 13 over 6 to the power of 1 over 4 it should be, and that's going to be equal to logarithm base 2 1 plus 13 over 6, it's going to be equal to 6 times 1, 6 plus 13, 2 to the power of 19 over 6 to the power of 1 over 4. If it is like that, power of power, we are going to multiply the powers. 1 over 4 times 16 over 9, 19 over 6 is going to be logarithm base 2 to the power of 19 over 24. And this 19 over 24 can be written now because it's only 19 over 24, can be written in front of the logarithm sign, and it will be equal to 19 over 24 times logarithm base 2 and 2. Yes, this is equal to logarithm here. Logarithm base 2 is equal to 1. So the answer is 19/2.